Hello everyone. It has been a very long time since we have updated our table of contents, so let's do that right now. This is what yours should look like. There are a bunch of labs that I haven't updated because I'm not 100% sure where you put your labs. Um, if or if they got switched around or not. So go through and find where those labs are or what's on page 10 and put that in. But over here on the right, we have all of these ones all the way down from Unit 1, Unit 2, and Unit 3. And this is where we are at now is Unit 4. On page 25, we talked about motion. And so let's put motion in there, and let's put Unit 4, kind of like we did for the other ones. And then today, what we're doing is Newton's laws. So, Newton's laws. And then we will be up to date for up to page 27 at least. So, let's go through until page 27. All right. So, first thing, page 27. I'm going to set up my Cornell Notes because that's what we're taking. So, put this all the way down, and then we do 2 across. And then I have my line over here. Let's put your name. I'm going to put Mr. Will up on the top right. It's going to be the 22nd. So 1, 22, 21. All right. We're titling this one Newton's laws. I wonder if I can adjust my light. There we go. Maybe that'll be better. Okay. So, our essential question, what are the laws of motion? There are 3 of them, 3 laws of motion, Newton's laws of motion. So let's start with the first one. So, first law of motion. And this one is called inertia. So let's underline that because that is a vocab word. And this one tells us 2 things. Things at rest, stay at rest. Things at rest, stay at rest. And things in motion, stay in motion. And these are true until, so we should put, or unless acted upon by an outside force. So, how do we put this? Unless acted upon by a force. So if there's an object just sitting there, it's just going to stay there unless we put a force on it. Or things are going to stay in motion or be in motion and stay that way unless there's a force. So if we throw a baseball, for example, it's going to stay going forever. But there is some forces acting on it. So air resistance, that's going to slow it down. Gravity is a force, and that's going to pull it down. So those things cause the baseball to kind of, well, hit the ground, and then the ground is going to cause it to stop because that's another force. So there are lots of things. But if we're in space, that's pretty cool. We could throw that ball, and it will go forever until it hits like a gravitational force or another object, I guess. But either way, that's kind of cool. Same with something at rest. So that's pretty cool. That's our first law of motion. Maybe we should underline that. First law of motion. Then we have our second law of motion. All right. And this one tells us to move a mass you need a force. And this one specifically deals with an equation. And that equation is F equals ma. So that's telling us the force is equal to the mass times acceleration. So if I wanted to move an object or make it accelerate, that's what acceleration is, I need to apply a force, which is kind of cool. Okay, so that's Newton's second law. And then we have the third law of motion. Okay, so the third law of motion is for every action, and you guys have probably heard this one before, for every action, there is an equal and opposite reaction. So for every action, there is an equal and opposite reaction. So if I'm on a skateboard and I push against the wall, well, I'm applying a force to the wall, but the wall is still pushing against me too, and that causes me to move away. It's kind of neat. Now, something that kind of interacts with these three laws of motion, specifically the things in motion stay in motion, is friction. Friction is a force acting in the opposite direction of motion. So if it's moving, it wants to push in the opposite direction. So friction is our vocab word. Friction. And it is a force in the opposite direction of motion. So we're going to draw a picture. So we've got a box here. Don't make it too big. Let's say it's on the ground. And if it is moving, so let's say this is the motion. If it's moving that way, the friction is pushing in the opposite direction. So this is the motion to the right, and the friction is going to be in the opposite direction, which in this case is to the left. Now, let's say we have a bunch of different forces. We need to add them all together, and that gives us something called a net force. So a net force, that's an E, obviously, right? Yes. And the net force is all forces acting on an object. Okay, so for example, we've got a bunch of examples. Let's say I have a box, and I'm going to draw a vector. We learned about vectors. So let's say my arrow is pointing to the right, and it's going to apply 8 newtons. And I have another vector to the left with just 2 newtons for A. So I'm going to draw another box right next to it. This is also A. My total, or my net force, is going to be 6 newtons to the right, because 8 in this direction and 2 in this direction, this one is basically subtracting from this one because it's opposite, and I'm left with 6. So it's like kind of just addition or subtraction. So let's try another one. Let's do B. Okay, so if I have 10 newtons this way and 2 newtons this way, well, my total, since they're both in the same direction, I add them. If they were in opposites, I'd subtract. But they're in the same direction, so my total is 12 newtons, which is kind of cool. Let's do one last one. Okay, so let's make this one tricky. We got, let's say, 5 newtons and 3 newtons, but over here I have 10 newtons. Well, this is 8 because 5 plus 3 is 8, but this is 10. So, well, this is obviously bigger by 2, so I'm left over from my basic math with 2 newtons of force. So these are the net forces, and these are the ones that I added up to get them. So these are Newton's laws of motion, and we're going to need to know them later on. So write these down, please, and I'll see you later.